So there's some different roof mounting configurations. For a residential roof or a small commercial roof, typically we are bolting the rack to the roof. And that means essentially we're going to make sure that we're attached to the rafters or the trusses that are holding up the roof. Mainly, we do not want the wind to be able to remove our solar panels. The whole array with the panels and the racks weighs less than 3 pounds per square foot. So it's not heavier than a layer of shingles. Some roofs, residential roofs especially, can have more than one layer of shingles, and then that could be an issue. For a larger system, like a larger commercial system, and there'll be a large flat roof area to put a big solar array, but that might be a rubber roof. What we do in that case is we ballast the system. So we have a system of trays and racks that you can put some bricks on to hold it down against the wind. We always have our architect or structural engineer check the roof to make sure it can hold the extra weight, because that's significantly heavier. If you have a standing seam metal roof, there's a neat system that allows you to clamp to the seam so you don't have to penetrate the roof. Nowadays, what we use for each connection to the roof, we use a flashing of some kind. The kind that we like hold the rack foot up off the roof. So there's an inch or inch and a half piece that keeps the foot off the roof, and then you can build your solar rack on top of that. If you have an aesthetics concern, you really don't want that panel look on your roof. If you're building a new house, add the solar roofing right then. First of all, you can design the house, the roof that makes sense for the solar roofing, and just build that right in. It's not that big a cost adder to your new construction. All right, next we'll take a look at some of the racking systems that we use for rooftop solar arrays. So first, you need to have a good watertight way of attaching to the roof. And we use some of these flashings that slip up under the shingles, and they have a raised foot of some kind that's already pre-sealed. So this is an aluminum sheet and aluminum foot. The lag bolt that goes into this has a big rubber seal on it and goes into this, and then the rack foot for your PV can go on top of that. That's one kind. Another kind, this is a little bit newer kind, it also has a raised seal. The rack foot comes with it and slips over there, and again, lag bolt goes in here, and the lag bolt has a rubber seal on it. So this is also a raised foot. It's not raised quite as much as the other one, but it is a little less expensive. We've used both kinds of these. They work really well to keep the attachments leak tight. Here's a little demo of one of these installed. The flashing has been slipped up under the shingles. There's several other kinds of these and other brands of these. This is another type, a standoff foot with a different kind of like a roof boot around it. So that's another way of doing it. Now once you have the flashings on there, then you're ready to put the rails on. This is a typical aluminum rail that goes on the L foot. So we've got an L foot that would be attached to your flashing, and the aluminum rail, it goes on that, and then the solar module is clamped down to the rail, and this is a clamp that goes from one module to the next. Then there's also an end clamp for the end of the row. All the clamps are either aluminum or stainless steel and have stainless steel bolts. Now once you have the flashings on there, then you're ready to put the rails on. This is a typical aluminum rail that goes on the L foot. So we've got an L foot that would be attached to your flashing, and the aluminum rail, it goes on that, and then the solar module is clamped down to the rail, and this is a clamp that goes from one module to the next. Then there's also an end clamp for the end of the row. All the clamps are either aluminum or stainless steel and have stainless steel bolts. So those flashings work well for shingled roofs. If you have other kinds of roofs, then there's other kinds of ways of attaching. One of our favorite ways is if you have a standing seam roof, you don't have to penetrate the roof. You can put this clamp right on the seam of the roof. So a standing seam will have seams that stick up probably an inch or inch and a half, and this clamp can go right on the seam and it clamps to it so it doesn't penetrate anything. And then there's a hole up on the top, a screw. You can put a screw in to put your rack foot on top of that. If you don't have roof space, or if your roof is shaded, or you just don't want it on your roof, you can also put something out in the yard. This is also great for larger installations. What we used to do is build a big honking concrete footer for your posts. If you want everything on one post, you can still do that. But more popular and cheaper is a driven post. So instead of doing digging and concrete, now we have this pile driver, I guess is a more proper term, that pounds the your post in down like 12 feet. What we're striving for now is quicker installation, a more efficient installation. Like driving the posts is cheaper because it takes a lot less time. So we're pushing to lower costs that way. Another nice thing about ground mounts is you can orient them perfectly. So you can orient them to face due south. You can tilt them for your optimal tilt. If you're doing an off-grid, then people like to have adjustable things, either an adjustable pole mount so they can shed the snow off in the winter. There's also trackers which can track the sun, which will improve your efficiency. However, tracker introduces moving parts. So now you have a maintenance item. And they're also more expensive. Standalone, so I did mention those before. They have a couple more components. You have to have a battery, if you're a standalone, and a charge controller which regulates the charging of the battery. And a lot more disconnects and fuses for a standalone. That is a low voltage system too. Most of those are 48 volt DC battery, and your inverter has to go from 48 volts to 120 or 240. And we will look at some more details of that a little later in our class. But for now, that's how you get electricity from light.